Good afternoon, everybody. My name is Lynn Hediger. I am Vice President of Manufacturing and Product Engineering for ORBIS Corporation. I think short of Dan, I might have the least known name, brand name in this organization or at this meeting. But I do work for a company that's fairly well known to some of your operations people, but maybe not necessarily to your groups. I work for a company called ORBIS. They are part of Menasha Corporation. Menasha Corporation is a fairly sizable packaging corporation. ORBIS is kind of the reusable side. Menasha Packaging is a sister company. They do the more expendable side. So what I'm going to talk about today is more of what ORBIS's experience has been with the world of IoT. ORBIS specifically, we do reusable plastic packaging and steel packaging. Most of it is plastic by nature, but it's things like the Amazon totes that you see floating around on their commercials. We do things like the pallets, bulk containers, bakery trays, all kinds of different plastic packaging as well. ORBIS, interestingly enough, is Latin for loop. The notion of it's reusable, it's recyclable. Okay, so sustainability is at our core. That is our big business. Some people say ORBIS stands for our real business is sustainability, or it could be service, but we are known in the industry for our quality and service as it relates to sustainable packaging. ORBIS is about $1 billion in sales. We eclipsed that for the first time last year, so we were excited about that. Have roughly about 50 locations. This is a bit dated, but 10 manufacturing plants in North America. About 3,000 employees, and we service just a variety of market spaces. Just to blast through just some of our key accounts, and we break our business down into retail supply chain applications as well as industrial and automotive. So again, very, very much household names that you'll see on there. We're known, again, for our innovation type of stuff, so we're going to make different packaging systems. I'm not going to go through this detail in the essence of time, but these were a couple products that we came up for the world of COVID. Everybody went into buy online, pick up at store, those types of things. We developed a lot of different picking systems for people like Walmart and Kroger and other grocery type of applications. As I mentioned, as we look at our view of sustainability, again, we're trying to do things not only to improve like how customers' ergonomics and how they handle stuff. They maybe don't have as much packaging waste in their environments, but we're also looking at things of how do we improve their carbon footprint for enabling them to be able to talk about their sustainability initiatives. This is an example where when they're sending a full load of product that's in the containers in the truck on the left, they get 84 containers on that truck. That might be going out from a tier 1 automotive supplier to an OEM. On the return loop, they can collapse those containers down and get basically a 3-to-1 ratio so that they're not having to pay as much truck transport to return it. So I know in the morning session, one of the people talked about the fact that a lot of times people can't drive their own sustainability, so they're looking to go upstream for it. We're one of those types of companies that they come to help them with their solutions that way. All right, enough about ORBIS. Not trying to sell ORBIS today. What I wanted to try and share with this group is just some specific details of applications where we've used sensors and so forth to improve our operations. Injection mold, we make a lot of plastic containers. I want to say last year we used about 400 million pounds of plastic. Roughly 40% of that is recycled content. Most of this is done on plastic injection molding machines. Very, very simplistic in nature on this drawing. Trust me, they're fairly complicated machines, but I'm going to keep it simple for you. Plastic drops in on the left side at the hopper. They come in granules, typically in from rail cars or bulk trucks. It goes into an injection unit, which is basically going to melt that plastic. There's a screw and barrel. The screw augers the material forward, creates some friction to help melt it. Then there's some heater bands around the outside. So that's what we would consider in a very simplistic model. That's the injection unit. On the other side of the center plate there where the nozzle is where the mold sits. And on that side, there's a clamping mechanism that opens and closes that mold. It's a hydraulic-based system. Most of our toys are fairly large. Some of these machines are upwards of 3,000 tons of clamp force. They're moving molds that are over 80,000 pounds a piece. So you can imagine they're very robust hydraulic type of systems. We are a 24/7 type of operation, so downtime is critical to us. We do schedule our presses at about 90%, so it doesn't give us a lot of fluff. We're very much like the airlines. When we have a mistake, we stack up late orders for days. So our ability to recover is fairly limited, so that uptime is critical to us. About 4 or 5 years ago, my team sat down. We were trying to figure out how do we drive our improvement for our uptime and reduce our unplanned downtime, obviously. And so we put together some goals of trying to, what would we want out of an IoT system? And we sat down and said, well, first and foremost, like everybody else, we want a predictive maintenance model instead of an interval-based model. We were very religious about interval, but we wanted to get to that, something that we felt was going to be more value added. As part of that, some of you guys really like your charts. Again, I'm coming from an executive view on this. I'm an accountant by trade and dabble in engineering, but you're going to get the view of an executive here. I don't want to look at your charts. They're way too complicated. I want a dashboard that tells me that I need to check my oil. I don't want to have to try and know when to check my oil other than when it tells me that. So we were looking for something very simplistic because we know not only those of us with a 5-minute attention span, but a lot of the people on the shop floor also don't have the understanding of all those charts. So we wanted something, a very simple dashboard, a check engine light, if you will. Just like everybody else, wanted to improve our uptime. We wanted to lower our procurement cost, reduce the amount of spares that we were carrying. And another one here is to reduce our troubleshooting cost. Too often we were sending people out to the floor. They were spending too much time doing diagnostics because they don't know why the machine's not running. Is it the hydraulics? Is it the controls? They don't know where to start, so they start with everything. We wanted to have something that at least could tell you the reason this thing is down is because of X. Go out there and look at that. So likewise, to our improved field service, our suppliers tended to send in a technician. Again, you say your machine's not running, they send a tech out. Maybe they sent the control guys and it turns out to be a hydraulic issue. He shows up 2 days later, says it's not what I can fix, makes another phone call, it's another 2 days before the next technician can come out and help you. So we wanted to get better with that. And then as our machines have gotten better in terms of their control systems and stuff like that, that ability to remote in and just take care of it without even having to send a tech was important to us. The bottom one is, was near and dear to my heart as we were putting this vision together. You know, ORBIS has 92 molding machines. Are we ever going to build enough history to know if we're making a difference or what's really happening? Or is this just an anomaly, one-off type of thing? So I wanted to be able to put the onus back on our suppliers to say, hey, you got tens of thousands of these molding machines out there. Connect up all of them and you can learn and teach us and we'll teach you and make a symbiotic relationship out of this. So we were trying to push the onus back upstream. Related to that is ultimately we wanted them to improve their product design, make a more robust machine, and if, at least in the interim, shore up your supply chain. In other words, if you're hearing from all of us customers that we're consistently seeing a pump failure, go back to your pump supplier and let them know that so that they can improve their systems, but in the meantime, go ahead and at least shore up your spare parts inventory so that when we call, we can get something the next day. So that was kind of our vision for what we were looking for out of our IoT approach. We chose to work with our largest press supplier, which is a company by the name of Millicron. Again, another company that's been around forever. Very well known, but Millicron was also not capable of doing this type of technology. We went to them and said this would create a competitive advantage. There was nobody in the world of injection molding that was doing IoT per se. So we gave them our vision. They liked what we were talking about, thought it was a service they could sell. And so they partnered with a company by the name of EI3. And the EI3 really was the team that was able to put the data scientists behind it. We knew at the ORBIS level, we weren't going to hire a bunch of data scientists. Millicron knew they weren't going to hire a bunch of data scientists, but we found the right partner to go work with, and that's who they do today. The goal really being, we wanted their systems to be able to tell us which part should we be ordering, and again, not just a whole bunch of charts, because we're going to drown in the data. Again, just a little plug on EI3. Again, they're not the biggest name out there either, and it's somewhat because I call them, they hide in the background, and they let these OEMs, so companies like our sister company uses Bobst flatbed die cutters. Bobst uses EI3, so they're branding it in the background as, oh, it's Bobst IoT or Millicron's IoT. They're leveraging other partners along the way. So where are we at this point? So ORBIS again jumped in as a beta partner to Millicron and EI3 back in 2019. We have a facility that's only a little over an hour away from Millicron's manufacturing facility. It made it very convenient for them to bring resources out, load up sensors onto our machines, and we could figure out what sensors were actually going to tell us what we needed to do. So we did go through the pain of having to deal with some failures and stuff to learn, but we got to a point where we started getting some pretty reliable information back from the system. Today we've got 22 of our 92 machines are connected. There's 34 different things that we're actually monitoring on each of these machines, and there's 250 unique algorithms that are being calculated a lot. Again, from the 5-minute attention span people, we did get our dashboard, our check engine light, and there's a little bit of a snippet over on the right side. Each one of those green boxes or red boxes is a press. So we can look at that very quickly. The maintenance team can look at that and say that press is good for today. I don't have to go look at it. We've put in things like just even, I've seen people talk about having to do the rounds. You got to go out and check the oil level on the sight glasses and check that the pressure valves are at the right points. We don't do that. All that stuff's captured. If it's in the green zone, you see a green box. If it's in a red zone, doesn't mean the machine's down. It just means there's something you should go take a look at. And we can drill into that. So an example is in the bottom. One of the machines that day was showing that it had 3 of the heater bands that were bad. Okay, it didn't mean that those heater bands had full failed yet, but it meant it's something to go take a look at before they're starting to fail. They're showing signs of it, and I'll go through that here in a second. So today we really have challenged, we did a Pareto analysis. We were actually very data oriented, had a lot of history, and we were able to say, okay, these are our top 3 or 4 items that were causing our downtime. And it was heater bands, hydraulic pumps, and then the feed screws on the machine. So we started off with heater bands. And I would have said the team within maybe 2 to 3 months came back to us and said, here's an algorithm that's going to tell you whether that heater band is on its way to failing or not. And so they gave us the fancy little charts, and to be honest with you, I don't really care what's happening in the background. Again, 5-minute attention span. I look at it and I go, well, okay, they told us, the data scientists told us. On the bottom one as an example, when the green line and the orange line start to separate, that heater band is starting to draw amperage at a different level than normal. It's on its way to failure, all right? So it's not failed yet. It would flatline if that happened, but what they're showing us is, yep. So our maintenance team could go and look at that if they wanted to. I will tell you, most of them are gonna look at it now. They trust the data at this point, that on that previous screen, it says heater band 3 is going bad. They just go replace heater band 3. They don't even come in and look at the data anymore. We've gotten to that level of maturity, I guess. Nice part about this, on these 22 machines only, the first year we saw over 7,000 hours of unplanned downtime go away. Because we could then we could get to a point where when a heater band was failing, we could schedule it to be replaced while we were doing a mold change. And now we're not incurring the extra downtime. So it was a huge win for us. We also started to see part quality better. So typically in our world, 3-4% scrap rates are pretty normal. We saw a 1% drop in that. And that really is just because when a heater band goes out, the material isn't at the right melt temperature. You start getting short shots, or what we call unmelt, meaning the plastic didn't melt all the way. And so you get defects. We've been able to reduce that by 1%, which was, again, a nice bonus for us. The next one that we took on was pump health. And again, the hydraulic pumps is the next biggest pain point that we would have. Pump goes bad. It tends to disintegrate. It throws what we call glitter into the oil. So the brass starts to come undone, and it tears up your machinery as a result. So they were able to they developed, the EI3 team in Millicron developed what they call their Symphony vibration sensor. It's also a sound-based sensor. But they could start to track, and you can see in the upper left-hand corner where that particular mold running was typically normally on the lower end of that range, and all of a sudden we started to see a ramp up. And so we took that pump offline where the red line crosses and said, let's just go ahead and proactively replace it. Sent it out, had the pump tore apart, took a look, and on the inside it was all galled up and about ready to fall apart. So it was a good validation for us. We had another one, the second one, same thing. So we were able to use that technology now where we can create predictions on this. What's not really clear on this is the time horizon. We can tell about 2 months before that pump's gonna go bad, that it's gonna go bad. So it gives us plenty of time to get spare parts in. I'll be honest with you, we carry these pumps in our stock anyway, but now we don't have to carry as many because we know we can take that one and have one backfilled and on hand before we never need to do that swap. So that's worked out extremely well for us. I will give the data science credit. Again, I'm not going to try to understand, but I will give them credit. So I'm going to use the top example where there's some orange and blue dots. Part of that is noise. That's the same chart that I showed you from the previous page, only shown with 2 products running on that machine. So in other words, we have 2 different molds that we run on that product. The orange one, we typically run on the high end of the range, and it didn't look like anything was unusual if you would have only looked at your data based on that tool. But the other product wasn't maybe taxing the machine as much, but over time you could see that if I took the orange away, you see that ramp up. We would have never seen that if we were only analyzing the orange one. So my point of saying that is there's a lot of data they got to try and a lot of noise they got to ferret through and decide, is this really something that's going to create a false positive? Or is it something that's real? So I give them props for that sort of thing. The pumps, for us, it doesn't show like it's a huge savings. You know, it shows 48 hour, roughly it's about a day and a half to 2 days to transition that. But the reality is if we don't do it, the glitter oil then starts tearing up the valves, it starts tearing up the seal kits in the machine, and we have all kinds of problems. So it becomes a multiple month just series of issues if we don't take care of it. It's not perfect yet. I say we're batting about 750, which for those of you that are baseball players would understand that analogy. That's pretty damn good. 3 out of 4 in the last year of the pumps that we've had fail. We did have one that slipped through and they didn't catch it. We're not exactly sure why that happened, but it gave us a new point to look at. What we think is that the machine had been down, they started it back up, and we had an almost instant failure. So we're guessing it was more of a mechanical issue than something that came in over time. This one I'm going to gloss over a little bit, but one of the nice parts, this is for our feed screws. We started analyzing energy, so we didn't have to put any new sensors on. We were able to take information coming from the machine, put it into a machine learning type of environment, and it could tell us when we were starting to see ramp up of electrical usage. That became an indication for us that our screw was wearing and would give us enough notice that we could get a replacement ordered in time. Screws typically 8 to 12 weeks to get one, so it gives us plenty of notice to be able to react to that. It's also given us the opportunity to make more parts per year because it's giving us feedback as to how we've got the machine set. So there's times where you're over processing, sometimes you're a little bit under processing. This gives us the sweet spot as to how to set that machine, and we can maximize our pieces per day, per year, whatever. They've also been able to teach us what is the right velocity we should be turning that screw to get the proper amount of melt, but don't over process it. So we've saved, on one machine alone, we saved over 18,000 kilowatt hours for that 1 year. So again, it helps us with our sustainability story internally as well. So what's next for Orbis? You know, again, I told you we got 22 out of our 92 machines are hooked up. I want to get the rest hooked up. So for us, it's rolling that component failure algorithms out to a wider variety of machines. One of our challenges is I told you we partnered with Millicron on this. We have a lot of machines that we've done acquisitions or whatever. We've got multiple vendors. So how do we take that and move it over to some of these other vendors? And we need to work through that. We want to just expand the breadth. You know, as you continue to look down the Pareto, well, those top 3 items aren't the top 3 items anymore. So what's next, right? For us, it's robots. The robots that are with the machine will take the machine down too. So how do we get onto the robot side of things next? We want to continue to leverage the machine performance analysis for us, being able to take advantage of the energy savings, report that out in our corporate social responsibility type of reports. And the last thing, we've actually accomplished this one, but it's the ability for the system to be able to tell our enterprise asset or CMMS type of system, it today is creating the work orders for us. So we're not just getting a notice saying, hey, your heater band's going bad. It's now taking it to a step where the team doesn't even go look at that dashboard for the heater bands anymore. When the maintenance team comes in the morning, they've already got a job packet to go and replace the heater band that's going to go bad. So we're already routing it right back through other systems, linking these things to make it smart all the way back through and be able to create that work order right away. And at the same time, it'll look at our internal stock and say, do you have enough of these things to complete that job? If so, have you tripped a reorder point? And that'll actually even go right to our procurement department to say, you need to replenish the stock of heater bands. So that's where our vision is to be able to take it all the way back through. And I think that's about what I got.